Today's lesson is on augmented matrices, and if you are numbering it, if you want to go along with your teacher's numbering system, this is 3.4. So an augmented matrix represents the systems of equations written in standard form. It includes the variable's coefficients in the first three columns and the constant term in the final column. So these are your constants. So we've been dealing with this. We have three equations, three variables, and it equals to a number, a constant. So to write our augmented matrix, we take the coefficient that is in front of our variable and we write those down. And they have to be in order. Our x's have to line up, our y's have to line up, and our z's have to line up. And then our constants line up on the other side of the equal sign. So the dimensions of a matrix indicate its size and structure. The first number represents the number of rows, and the second number represents the number of columns. It is written in the form rows times columns, such as 3 times 4. The way I remember this is, has anybody ever heard of RC Cola? It's an old-time Coca-Cola drink, not Coca-Cola, but so RC, that's the order we do it, rows by columns. This would be 3 rows, 1, 2, 3, and then 4 columns, 1, 2, 3, 4. So example 1, rewrite the system of equations in an augmented matrix, then state its dimensions. So all we're going to do right now is we're going to rewrite it into the augmented matrix form. So let's draw our matrix little brackets. We have a 2. Don't forget your sign. -9. If it doesn't have a number, what is it? 1. That's right. So put -1, even though there's not a 1 there. And then here we have these dotted lines. You could just draw a line just so that you can keep it straight that this is what it is equal to. My second row is my second equation. That's 1, 1, 1, and then it's equal to 2. And then my last equation, I didn't leave enough room here, but that's 4, -3, -2, and a +7. What is its size? Its dimensions, remember it is rows by columns, and so it is a 3 by 4 matrix. So we can go on and do the rest of these. For my first equation, I have a +1, then a -3, -1, let's draw our line here, and then 19. Look, do I have an x in the second equation? I do. It's just moved over. So that's a 2. I'm missing something. What I'm missing is my y right there. So my coefficient is going to be 0. I have 0 y's. Don't forget to put a 0 to hold its place. And then for z, I have -1, and then my constant is 2. Third equation, I have all 3 variables in that one. So 1, 1, -3, 11. Again, it is a 3 by 4. The last one, you might want to pause it and do it yourself to make sure you're getting it, and then come back and check and see if you got it right. 1, -2, +1, 31. Ooh, I don't have an x, so that's 0. 2, oops, no, see, I messed up right there. It's y. I was looking on to the z. So this is 1, this is 2, and then 12. And then my last equation, 2, -3, -1, 29. Again, 3 by 4. Most of the ones that we're going to be dealing with are going to be 3 by 4s because we're dealing with solving 3 equations. So this is the part that you have been waiting for. Everybody's like, is there a way to do this in the calculator? We're going to show you now. With most things math, we want you to know how things work. How do you do this? Sometimes when you get to college, you will not be able to use a calculator in some math classes. And so you need to know how it works, and that's what we did. Now we're going to show you how to solve it using a calculator. You still have to put it in correctly. So there are steps here, but I'm going to write the steps out for you, and there's also going to be a document on Canvas for you to refer to, and then I'm going to show you how to do it. So you can use a graphing calculator to reduce an augmented matrix to reduced row echelon form. That's going to be important. You're going to see that on your calculator, RREF, to calculate the solution to a system of linear equations. So steps. You're still going to align all variables on left side of the equation if necessary. Write an augmented matrix to represent the system. So sometimes even if we let you use your calculator, we might ask that you write down the matrix on the test. 3, enter the augmented matrix into the calculator. So these are the steps I'm going to give you right now to be able to do that. So to do that, the first step is, and you may not have room to do all of this, you may want to write it somewhere else. But you're going to press the menu button on the calculator. I'm going to write these down and then I'm going to show you what it is. 2, you're going to choose number 7, which is matrix and vector. Your third step, from there it's going to give you another pull down, and you're going to choose number 5, which is the reduced row echelon form. And then you're going to see RREF. Let's write that. RREF and then parentheses. And it's going to have a little cursor there. So then the next step is you are going to, on your calculator, next to the number 9, you're going to see a button that looks like it's kind of absolute value, and it really is cool. It gives you all kinds of little options to do. It is the button that is right of number 9 on the calculator. So once you hit this, you're going to get a menu, and you are going to choose, it's a button that looks like a matrix, like what we're doing. It's like in the middle, exactly in the middle of the options that you have. So once you have that, you choose that, it's going to give you an option to show you to choose the size of your matrix. So it's going to say create a matrix, and it's going to have like number of rows, and it's going to have 3 as the default. You're going to leave that there, and then it's going to do number of columns. You're going to change that to 4. Then when you're done, you're going to hit OK. And then you're able to enter your numbers from your matrix that you created into the matrix on the calculator. Important thing, use the tab button to move. Let's see, I'm going to give you number 7. You are going to, I'm going to flip just a little bit, enter coefficients, and constant, and then you're going to hit enter. Okay, lots of steps. Once you get used to it, you're going to go through it pretty fast. They give you an example here. You need to create your matrix. Once you put that in there and enter it, you're going to have get a matrix in reduced row echelon form. Important thing, you're going to have the ones in a row like this. What that means, this is your X column, your Y column, and your Z column. So it means that your X is equal to 1, your Y is equal to -5, and your Z is equal to 6. And so that's the answer right here. So let's do the example 2. Okay, I have my 3 equations. Let's turn the calculator on. We are going to press, here, let me do escape. How do I get out of that? Okay. Menu. You're going to go down here to the matrix and vector, number 7. You can click it there, or you can just do the number pad and hit 7. Then you're going to do the number 5, reduced row echelon form. And that's where I told you you're going to have the RREF and parentheses. Your cursor is inside of the parentheses. So now next to the number 9 is this button that I told you about. Press that. You're going to move over to the middle to the matrix one. Oops, sorry you couldn't see that. There it is, right there. Hit enter, and then you get create a matrix. We want 3 rows. It's easiest to use the tab button to go in between things, and then you can delete that, or you can use the arrows and choose 4 columns because we want our answer to be in there. Then hit the tab again and hit OK. And now you have your matrix. So we did not create our matrix here on paper, so let's do that first so we know for sure what to put in. We have 5, -6, -4, and then 10. So we've been drawing that line. It's not on the calculator. You're not going to have a line there. It's just to show you that that's where your answer, just a dotted line, whatever. Then 3, 4, 7, +2, 9, -8, -3, 18. So once you have that, then you can start putting the numbers in. 5, hit the tab button to go. It's the easiest way to go back and forth. I like to use the negative underneath the 3, but you can use the minus, but it's good to have it to use the negative for your negative numbers. -6, tab, -4, tab, 10. Then your next row is 3, 4, 7, 2. And then your last equation or row is 9, -8, -3, and then 18. Double check. Make sure you got everything right, because you don't want to get the wrong answer. And then when you double checked it, you're going to hit enter, and you get your answer. You see how you have your ones in a row and the others are zeros, and then these are your answers. So you're going to get, you can write that down if you want to. I'm just going to write that down now. This is what you're looking for. What that means is that x equals 0, y equals -3, and then z equals 2. You can also write that as an ordered triple. Maybe your answer is going to be in this form: 0, -3, 2. Remember, alphabetical, x, y, z. Okay, let's turn the page and let's look at some special solutions. So when solving with augmented matrices, a 3x3 system of equations with no solutions, because sometimes we get that, we'll produce a matrix with the final row in the form of 0, 0, 0, 1. So there's no 1 here. Is this a true statement? If you got that answer, you would say no. That is a false statement, because 0 does not equal to 1. So besides no solution, we know that our other special solution could be infinitely many solutions. It will produce a matrix with the final row in the form of 0, 0, 0, 0, which is 0 equals 0, which is a true statement. And so that's what we used before to say if 0 equals 0, then our variable is eliminated, and therefore if we get 0 equals 0, that's a true statement. Our answer would be infinitely many solutions. So let's see what that would look like. Example A. If we wrote our matrix, we're going to have 7, -2, +3, 6, 12, 1, -4, 10, 21, -6, +9, and 9. Pretty soon, y'all are going to get so fast at putting in these. You could go up and grab the matrix before that, but I find it easier just to start from scratch than to grab that. So whatever's easier on you. So let's start with menu, number 7 for matrix, number 5 for reduced row echelon. Now I have the RREF in the parentheses. So next to my number 9, I'm going to click on this button here, And look, since I just did it, that matrix is already up. I don't have to search for it. And so I'm going to hit enter. My rows is correct. I just need to change my number of columns. I'm going to tab over to get to the OK, hit enter. I have my matrix. So I'm going to put in my numbers. I'm using the tab to go to the next one. -2, 3, 6, and it takes you down to the next row, the beginning of it, which is very nice. 12, 1, -4, 10, 21, -6, 9, and 9. Hit enter. Does that look right? See, that looks different. I have a 1, 1, I have a fraction here, and then I have a 0 here instead of a 1. 0 equals 1. Is that a true statement? No. And so you could put 0, you could write the whole matrix down, or you could say 0 equals 1. That is false. And so that is no solution. Okay, for example B, let's create our matrix. I have 1, -1, 1, 24, all ones, all positive ones, -8, 2, 1, 2, and 0. Let's put that in. So hopefully y'all are getting good at this now. Menu, 7, 5, I got my RREF, hit the matrix button, enter, tab, down to the next one, put 4, tab, OK. Sometimes if you hit the up and down arrows, it changes your number. I've learned that from experience. Tab is your friend. So let's put these numbers in. 1, -1, 1, 24, 1, 1, 1, -8, 2, 1, 2, 0. Did I do it right? I think it looks right. So now when you look at this, your bottom row, you have 0 equals 0. So let's write that down. 0 equals 0, which is a true statement. And we know that when that's true, our variables eliminate, and we have 0 equals 0, then our solution is infinitely many solutions. Now what you love, word problems. A baked chicken breast contains 32 grams of protein, 4 grams of fat, 0 grams of carbohydrates. So it's going to go through and list all these. Like for serving of whole wheat pasta, we have 7 grams of protein, 2 grams of fat, and 41 grams of carbohydrates. A serving of pasta sauce contains 2 grams of protein, 1.5 grams of fat, 13 grams of carbohydrates. How many servings of each are needed to supply exactly 45 grams of protein, 10.5 grams of fat, and 80 grams of carbohydrates? So this problem is a little different from the other ones that we've had, but we know that we need 3 equations. One of them is going to be the number of grams of protein. So I'm going to highlight that in green. And so I'm going to go up here and I'm going to highlight my other protein amounts in the same color. So protein, protein, protein. My other equation is going to equal to grams of fat. So 10.5 grams of fat. So here's my fat. There's 4, 2 is fat, and then my last one, it's 1.5 grams of fat. And then carbohydrates, 80 grams of carbohydrates. So let's highlight my carbohydrate amounts in pink. There. But my variables are going to be C for chicken breast. This is number of servings, because we want to find out how many servings of each of these things do we need to get that amount of protein, grams, and fat. Protein, fat, and carbohydrate. That was it. So C equals chicken breast. My P is going to equal to the pasta, whole wheat pasta, and then S for pasta sauce. So let's create our 3 equations. So my first one for protein, remember that was our green. So for our chicken, we will get 32 grams of protein for each serving of chicken, plus 7 grams of protein for each serving of pasta, and then 45 grams of protein for each serving of pasta sauce, which is an S. Don't get your 5 and your S confused. And that will equal your total amount, which is 45. So next, we're going to look at our fat. Fat are the ones that were highlighted in yellow. So for each chicken breast, we get 4 grams of fat. For each serving of pasta, we get 2 grams of fat. And then each serving of pasta sauce, we get 1.5. That's a plus 1.5, and that equals your total amount that we need to try to get is 10.5. And then our carbs. Those were our pink. So for our chicken breast, we get 0 grams of carbs. Our pasta, we get 41, lots of carbs in pasta. And then for our pasta sauce, we get 13 grams of carbohydrates. And our total amount that we're shooting for is 80. So now we have 3 equations, 3 variables. We can create our, let's see, I'm going to move this up a little bit more so we can create our matrix. We have everything lined up, carbs, protein, even we have the 0 for over here for our C's. A lot of times you won't see this in an equation, we wouldn't write that. And pasta, and then our pasta sauce and our total number. So let's just write the coefficients, 32, 7, 45, and 45. Wait, is that right? Yeah. Nope, because this number is supposed to be 2. Did I write that down wrong? Yeah, 2. This should be 2. This should be 2. And this is 45. See, why are we having 45 twice? See, you need to go back and look and check your answers, see what you did. Our equation for fats, it's 4, 2, 1.5, and then 10.5. And then we have 0 for our carbs, 41, 13, and 80. Okay, does everything look right? Did we do it right? Now we are ready to put it into our calculator. So menu, 7 for matrix, 5 for reduced row. We get RREF, click our button, enter. 3 is correct, change it to 4, tab to OK, hit enter. So let's put in our numbers, 32, tab, 7, let me get over, both, tab, 2, 45, 4, 2, 1.5, 10, 0, 41, 13, 80. Hit enter. Oh, you know what? I think I got one of them wrong. Did y'all see that? We got one of them wrong. What we do, if you realize you did something wrong, you're going to go back up, hit the arrow button, and highlight that matrix that you just put in, hit enter, and you can go back and enter. So instead of 10, I needed to do 10.5 right there. I can put 10.5. I did that one wrong. Now let's hit enter. That looks so much nicer, doesn't it? So my answers are x equals 1, my y equals 1, and then my z equals 3. Which, this is my chicken, this is my pasta. I said x, y, z because that's what we normally think of. And this is my pasta sauce. Yeah. And so my triplets would be 1, 1, 3. Hopefully you also learned how to edit a matrix in case you do something wrong, because we all do that sometimes. Good luck, have fun. I still want you to know how to solve matrices, but the calculator can be a great tool if you're able to use it.